College, Moolamattam. Hearty welcome to you all to the webinar series organized by the Department of Physics, St. Joseph's College, Moolamattam, as part of the Student Enrichment Program. I hope all of you are doing great in this unprecedented situation in which all our studies and work have gone online. Let this pandemic situation does not break our further studies. Today, we are on the first webinar of the webinars, St. George's College, Aruvithara. He obtained his BSc degree with the first rank in MG University from St. Joseph's College, Moolamattam, and MSc from St. Thomas College, Pala. He obtained his PhD from NIST CSIR, Trivandrum, and he worked as postdoctoral research fellow at University of Kolkata and also at University of Nova Gorica, Slovenia, Europe. He contributed one chapter of a book published by Nova Publishers, UK. He has 24 research publications in reputed international journals and presented 20 research papers in national and international conferences. Dr. Sumesh George was the recipient of Young Scientist Award in Kerala Science Congress 2009, and he is the reviewer of many international journals. His research interests include microwave dielectrics, microwave antenna, LTCC, etc. He used to deliver popular science lectures and motivational talks in academic and public platforms. On behalf of the Department of Physics, St. Joseph's College, Moolamattam, I extend a hearty welcome to Dr. Sumesh George. I would like to mention with gratitude Dr. ABP Koshi, Principal, St. Joseph's College, Moolamattam, Reverend Dr. Jose Nedubara, CMI, College Manager, Reverend Father Libin Veliparambil, CMI, Bursar, St. Joseph's College, Moolamattam, Dr. Anju P. Matthews, Head of the Department of Physics, St. Joseph's College, Moolamattam, Mr. Amal J. Adagat and Mr. Sijo John, the technical team. So before we begin, I request all the participants to mute the audio and not to present yourself during the presentation. At the end of the presentation, we'll have a discussion session. During the presentation, you can leave your doubts or queries in the chat box, or it can be asked later in the discussion session. Once again, I welcome all the participants from various capacities to this webinar. So enjoy the session and make the best out of it. Have a good time. Now, I invite Dr. Sumesh George to start the presentation. Over to you, Sumesh sir. Thank you.
Hello, Praveen sir. Am I audible to you?
Yeah. Audible.
Okay. So, I think the screen is also visible to you.
Yes. Everything
Okay.
is okay.
Okay. So, thank you, Dr. Praveen, for your nice introduction. Respected Head of the Department of Physics, Dr. Anju P. Matthews, Dr. Praveen, and my dear fellow participants for this webinar. First of all, I would like to thank the Department of Physics for inviting me to handle a session in this webinar as part of their student enrichment program. As everyone knows, for the last 6 months, we have been suffering from the so-called pandemic, COVID-19. Do you know which one is the most repeated or most conducted experiment, especially in Kerala? Do you know which one is the most repeated and conducted experiment, especially during the lockdown time in Kerala? It is nothing other than the experiment that happened in kitchen. As everyone knows, kitchen is one of the best thermodynamic lab because we know that we are in kitchen, we are dealing with so many thermodynamic variables such as pressure, volume, temperature, and also the thermoconductivity of different materials, different food items. That maybe knowingly or unknowingly we are dealing with latent heat, specific heat capacity of different food items, and also some endothermic and exothermic reactions. All these we are dealing maybe unknowingly. So in this present talk, I would like to explain how the electric field can cook your dinner. Actually, cooking is one of the oldest technology. Just a second. Okay, so cooking is one of the oldest technologies. It is something that perfects the art of feeding ourselves. And we know that ever since the human discovered how to make fire, they started to prepare or started using the fire to cook the food. And the basic idea behind this cooking is to kill the bacteria and make something nutritious and tasty. That is the basic idea behind the cooking. But we know that is prehistoric one. But we don't know at that time they may aware of killing the bacteria using this fire. But anyway, they use this bacteria of actually from prehistoric time itself. They use the fire for cooking food. Actually killing the bacteria and something nutritious and tasty. And cooking techniques have become sophisticated and efficient, as well as more portable and compact as the time evolves. Actually, that is the lifestyle of people. That means instead of sitting around smoky wood fire for several hours, people have just tossed everything in an induction cooker or microwave oven, pressed a few buttons, and had meal ready in a minute or two. So that's the advantages of the development of sophisticated equipment. We can see gradual development of this cooking technology. That is, actually starts from fire from wood, then gas. Then they started to prepare or they started using electricity for cooking by heating the electric coil. Then after that, induction cooker and microwave oven. So in the present talk, I would like to explain one of the leading technology that is most benefit rich cooking method, that is called induction. And induction ranges uses electromagnetism to cook food inside the pot or pan itself, which means that there is no direct flame from the burner. Actually, it uses a strong electromagnetic field, or not electromagnetic field, strong electric field that actually cook the food, or that actually generate the heat within the pot or pan itself. And you know that in induction cooker there is no direct flame, which means that it is safer, and the heat is actually generated within the pan itself. So which means that it is highly efficient. And usually the conduction or cooking is by thermal conduction from the burner to the pan and then pan to the food. But in induction cooking, heat is generated within the pan itself. So before discussing the science behind the induction cooker or induction cooking, I would like just go back to the history behind the induction cooker. People witnessed the magic of induction cooking or induction cooker first time in World Fair in 1933, and the induction cooker demonstrations were held at GM, that is General Motors in North America, by Frigidaire division of General Motors, and productions were delayed for another few more years, and for subsequent 40 years the technology was used mostly in industrial applications. And after that, the modern developments and implementation of induction cooking starts in early 1970s at R&D Research and Development Center of Westinghouse Electric Corporation, USA. And after that, induction cooktop uses transistors developed for automotive igniting system to drive 25 kilohertz current. Actually, it works at a frequency of 25 kilohertz current, which is well above the audio frequency range. And they developed the first cool-top induction cooker. That is Westinghouse developed their first cool-top 2 CT2 induction range by a team led by Bill Moreland and Terry Malarkey. Their induction ranges includes a set of high-quality cookware made of quarter play, which were priced around $1,500. That means now it's maybe 1 lakh rupees. That means a single induction cooktop costs 1 lakh rupees. That is very high. But after with the recent development in technology, induction cookers are now better than ever, while cheaper manufacturing from China that reduces the cost of induction cookers to the level that being affordable to every household. That's the present situation. And currently, induction cooktops are a norm in newly construction in many European countries. just like in Kerala itself, for getting a maybe permit or building permit, they have a set of rules like we have to install some wastewater collection pond or water harvesting pond we have to build. So then only we will get the permission. Just like in Europe, we have to install the induction cooktop for getting permission. In Asia, similar phenomenon has occurred, and huge number of Asian households are switching to induction for their cooking due to their safer and a cooler cooking environment it provides. So that's about the history behind the induction cooking. So when we think about cooking, there's a question that how we can generate heat without fire. Usually, without fire, fire is responsible for the heat. Here there is no fire, so there may be a question that how can we generate heat without a fire. So induction is the term that refers to a specific method for generating heat. Induction cooktop uses induction to heat the food without any flames or direct heat, cooking more efficiently than the conventional gas or any other means of conventional cooking. It is more efficient, that we will discuss later, the efficiency of this induction cooking. And induction cooktop uses a principle called electromagnetic induction. So next we will discuss about, before discussing induction cooker or induction cooking, I would like to just mention what is electromagnetic induction. In a nutshell, induction means generating electricity using magnetism. Two different aspects of same underlying phenomenon, that is electromagnetism. We can call these two faces of the same coin, or two sides of the same coin. That is induction or electromagnetic induction. And most of the science students, they may know James Clerk Maxwell, who described the science of electromagnetism with his four well-known equations called Maxwell's equations. Before discussing the working of induction cooker or induction, electromagnetic induction, I would like just to go back to the scientific background. So a group of brilliant European scientists, they figured out the science of electromagnetism. So scientists had known electricity since ancient times, but understanding the science behind the electromagnetism or electrodynamics that actually powered the world. A Danish scientist, Ørsted, he found that when a current flowing through a conductor, an invisible field that is generated or formed around the current carrying conductor, that's we call magnetic field. So this Ørsted, he proposed that when a current flowing through a conductor, the magnetic field is generated. And electricity and magnetism, they are the sides of the same coin, or two sides of the same coin. And electric field will exist even when there is no current, because if charge is, suppose we place a unity charge there, there is a possibility of, not possibility, there is an electric field is around that. But for magnetic field, there should be a change in, or the charge should be in motion, or charge in motion, we call this one as current. Magnetic field occurs only when there is a current flows. And next year, French physicist André-Marie Ampère, he took the experiment to further stage or another stage. He found that when two wire carrying current placed near to one another, it will either repel or attract. That's the thing that will either repel or attract when current passing through two wires which are placed nearby. What happens is the magnetic field is generated within these two these two wires, depending upon the direction of the current. Suppose both the currents are flowing in the same direction, both the wires, and there's a possibility of repulsion. If they are in opposite direction, there's a possibility of attraction. So this was proposed by Ampère. And next, we have seen that Michael Faraday, a British English physicist and chemist, In 1821, Faraday figured out how to use electricity and magnetism to develop very primitive electric motor, and he showed that a rotating coil of wire through a magnetic field would make an electric current, and that is inventing the electric generator that would soon bring the electric power to the world. Actually, that is the means the real phenomenon behind the invention of electricity. So that is proposed by Michael Faraday. And science of electromagnetism was finally nailed by, as I told you, Scottish physicist Abraham James Clerk Maxwell. Maxwell summarized everything that was known about the electricity and magnetism at that time with these beautiful four equations called Maxwell's equations. The first one, I think most of the students may know about this, the beauty of these four equations. Del dot D is equal to rho, that is Gauss theorem itself, and del dot B is equal to 0, which means that magnetic monopole does not exist. And the third one is nothing other than the ambient circuit law, and the fourth one is Faraday's law itself, the rate of change of magnetic field that creates the electricity. So that is about the history behind the scientific history behind the induction, electromagnetic induction. Now, I would like to describe you how induction cooktop works. So before discussing the working of induction cooker, I will just tell you what are the things inside this induction cooker. You can find a copper coil. Actually, this is the heart of this induction cooker, and you can find a fan for cooling. And there are a lot of electronic circuits associated with this. And there is a temperature sensor, and there's a thermal grease for thermal isolation. And top of this, there's a ceramic or glass plate, which is used for separating this electronic equipment from our pot. So that is the inside view of induction cooker or induction cooker as such induction cooker. Now we are moving to the important part, that is how this induction cooktop works. As you know, induction cooktops is just like other electronic equipment that uses electricity to generate heat. This induction cooker, it uses a powerful magnetic field, That's the reason why most people worry about it, whether it affects or whether it's harmful to our human body, or how safe it is. So that end of this part, I will discuss the safety features of this induction cooking. And with induction, there is an electromagnetic reaction between burner and the pot or the utensil that you put in this induction cooker. You can find electromagnet, there's a power coil, electronic supply, then ceramic top, which means glass plate, and above that we are placing a pot or pan for cooking food. Since actually the induction cooking is nothing other than electromagnetic electromagnetic reaction between the burner. We can call this one as a burner, electromagnetic reaction between the burner and the pot. And this induction cooker or induction cooktop that works at a frequency of 24 kilohertz, which means that it's well above the audio frequency range. It is used for actually it isolates the audio frequency range. We cannot hear the frequency of this magnetic field or the current. And the right underneath of the cooking area, induction cooktop, is tightly spiral copper coil, and copper coil is driven by the alternating current. And if you put a ferrous material, all the pans cannot be compatible with this induction cooking. There are certain type of vessels that can be used for induction cooking. All vessels cannot be used, which means that some ferrous type material or ferromagnetic materials can be used for this induction cooking. If you place a ferromagnetic material or ferromagnetic pan just above the induction cooker, what happens is when we give electric supply, what happens is the electronic circuit that circulate or that's give each or provide current at a frequency of 24 kilohertz. Since it is an alternating current means it is always changing at a frequency of 24 kilohertz. since it is an alternating current, if it is a direct current, there is a magnetic field is there. If it is an alternating current, the magnetic field is also there, but it is always changing. Okay, so the magnetic field is always changing, and at the same time, there is an electromagnetic interaction between this burner and the pot. So the magnetic field is always changing at a frequency of 24 kilohertz. So what happens is there is a current generated within the pot itself. That current is called eddy current. It's just like a swirls or eddy in water. It's just circulating. That I will show you later. And this eddy current actually responsible for the generation of heat, and this current back and forth, and the metal resists the flow of current, which means that there is a possibility of heating effect by Joule's heating. Most of the students may know about Joule's heating, which is I square R. Okay, so this eddy current that is responsible for the heat generated within the pan itself, and this heat is transferred to the food. And if you want to reduce the temperature, you just control the current itself. If you control the current, there is a possibility of reducing the magnetic field, then thereby reducing the amount of current that produced in the utensil itself. So this is actually what happens in the induction cooktop. So I think you may have noticed that for cooking each type of food, there is a provision for control options in induction cooker. For particular type of food, this is the option. A particular type of food, this is the another option. This is what actually happens is just controlling the current. Okay, if you supply more current, more magnetic field, more electromagnetic interaction, that means more eddy current is formed in the pan itself, ferromagnetic pan itself. So next, I would like to tell you about what is eddy current. Actually, eddy current is responsible for the heating in this conductive utensil. In layman's point of view, layman's term, eddy currents are loop of electrical currents that are created in the conducting materials by magnetic field that changes from positive to negative. See, in this figure, you can find that as the magnetic field is changing, see, there is an eddy current, which is always in the form of loop. And this current is responsible for the generation of heat within this pan itself. As I told you, when the current, if you give the current at a frequency of 24 kilohertz, that generate the magnetic field. The magnetic field is also changing as per the direction of the current, and through this electromagnetic interaction with the burner and the pot, eddy current generated in this utensil, and this eddy current is responsible for the heat that is generated within the pan itself. There is no heat produced by this coil or the glass plate. So so we can place a paper in between the glass plate and this utensil or this pot. You can place a paper, because this paper won't catch fire directly. It may catch fire after long duration of heat or heat transferred from the conducting utensil to the paper, but this not usually does not happen. It does not happen usually, because heat is not generated within the electromagnet. It is generated within the pan itself. So you can place a paper in between in between induction cooker and the pan. Okay, so actually the electromagnetic interaction from the electromagnet and the pan, so it won't affect the paper, won't affect, or paper won't perturb anything. So as these currents, the eddy currents, are not responsible for doing any useful work, and it produces a loss called I square R loss in the magnetic material known as the eddy current loss. So we can call this one as eddy current loss. This loss is responsible for the generation of heat, and the major heat loss during cycling eddy currents due to the friction in the magnetic circuit. So these eddy currents are basically due to the friction in the magnetic circuit. And this induction cooker have amazing benefits like its efficiency, safety, comfort level, control, and limitations. So first we discuss about the efficiency of this induction cooker. See, the efficiency of when we discuss the efficiency of this induction cooking, efficiency is induction hob is around 90% compared to the 70% gas or ceramic electric. So they are good energy saving. See, it is highly efficient because there are several reasons. The first one is actually heat is generated within the pan itself. See, in normal electric cooking method, first the electric coil that is heated, then the heat is transferred to the pan. Again, this heat is transferred to the food material. That actually what happens in normal electrical cooking. But here, heat is generated within the pan itself, so we can say it is highly energy efficient. And at the same time, if you compare the gas cooking method, there are a lot of flames, and it also heat the atmosphere itself. And at the same time, there are a lot of flames that may be wasted outside depending upon the size of the pan. Okay, so if we compare all those things, we can say it is highly efficient, and at the same time, less time is taken to cook the food. So less time is taken to cook the food means it is highly efficient. And according to popular mechanics, around 90% of electricity is consumed by the induction stove is used for cooking food. So there is no heat energy escaped into the atmosphere. That is one of the advantages of this the so-called induction cooking, which means that it's highly efficient. Now I would like to discuss about the safety features or safety of this induction cooker. Safety is an important aspect of induction cooking, and we know that there is no naked flame or fire, which is extremely unlikely. So there is no fire or there is no flame, which means that it is somewhat safe. So you know that if flames are there, fire is there, there is a possibility of chance of getting means any form of fire hazard. Here there is no fire. And the cooking surface is made up of glass ceramic material, which is a poor heat conductor. You know that you can easily touch the induction cooktop because it's made up of glass. It's a poor thermal conductor, so we can see that it is it's really relatively safe. And we know that there are a lot of control system associated with this induction cooker. And this animation itself, you can find that if pot is not there, it won't work. Actually, heat is generated within the pot. Somehow, if you forget to place the pot in front of a utensil on the cooktop, it won't work. Even though you powered or switch on the induction cooker. So if pot is not present or not, if not large enough or small, it won't work. And it also sends the overheating. See, in this animation, you can find that the part of the egg is not boiled or not cooked. Okay, so the egg or the chocolate is melted on the pan only. Suppose this is the chocolate is just placed on the induction cooktop, it won't melt because heat is generated within the pan. So in this aspects, we can say the induction cooker is safe than other means of conventional cooking. Okay, so we have a lot of control systems. If pot is not there, it won't work. And it also senses the overheating. We know that there are a lot of temperature sensor is there. It senses the temperature and automatically cut off. And when the temperature goes below, it automatically switch on. That's what is safety. That is the safety features of this induction cooker. Now, coming to the comfort level, induction cooker or induction has better temperature control when compared to the electric cooktop. As I told you, if you want to increase the temperature, you just control the current. If you increase the current, that automatically increases the magnetic field that leads to the increasing the eddy current in the pan itself. So it gives a precise control, or the comfort level is much higher. And induction cooktop heats up immediately and cool down quickly the glass surface. That is one of the comfort level. and the amount of heat generated in the cookware can be finely manipulated by control the strength of the magnetic field, as I told you. And another comfort level is, if suppose something fall on the induction cooktop, we can easily wipe out, which means that we can clean the induction cooktop very easily compared to other form of conventional cooking. See, you just imagine if something fall on your gas stove or conventional what we call fire like cooking. Okay, you just imagine. So this one is very clean and safe. And now I would like to discuss about the limitations of induction cooker. See, first I would like to discuss about the vessel specifications, with the utensil specifications. All the utensils or all the pans cannot work with this induction cooker. So it works with a pan made up of certain materials that have specific properties. As I told you, all the materials cannot be used for induction cooking. There are a lot of specific materials. I think just before I mentioned that ferromagnetic material or ferrous material, it is used for induction cooking, just like iron or steel. Copper or aluminum, which is not used for induction cooker, because the science behind this ferrous material used for induction cooker is that in ferrous material there is an unbalanced electrons. That unbalanced electron means, see this, for example, iron, it consists of iron is made up of means iron vessel is made up of iron atom, and it has more upspin electrons than downspin electron, which means that there are more unpaired electrons, or unbalanced electron, we can say unbalanced electrons. And these atoms behaves like a tiny magnet. So in our vessels, it consists of n number of atoms. These atoms behaves like a tiny magnet, and there's a possibility of interaction of this magnetic field with this tiny magnet that results the generation of heat. So if we place copper or aluminum, it won't work. But recently, I have seen that Panasonic company, they developed all type vessels. They developed a induction cooker which can be used for or all vessels can be used for the recently developed induction cooker developed by Panasonic company. But in that they used high frequency, very high frequency current for making this electromagnetic interaction. And to best way to check whether your vessel or pot is used for induction cooker is that you just place a magnet on the back of your vessel or pot. If it stuck, then it can be used for induction cooking. That is a limitation. Then another limitations that can be related to efficiency also. You know, electricity is a secondary source of energy, and gas or wood or something like that is a primary source of energy. See, electricity is a secondary source of energy, which means that during transmission, there is a possibility of, not possibility, there is a transmission loss. If you take that also into account, the efficiency is not that much means good. But if you take that also into account, efficiency is better than gas. But we should remember that electricity is a secondary source of energy, but gas is a primary source of energy. And another limitation is it works only when there is a power. If there is no, if suppose there is any electric power failure, it won't work. But gas, we know, it is a storage energy. We can say it's a storage energy. You can use whenever you want. But if there is a power failure, it won't work. And we can say there are a lot of advantages of this induction cooking. It's a planet friendly. We can say it's a planet friendly. Do you know why? It does not produce any flame or any smoke or anything like that. So in other forms of cooking, we know that a lot of flames, a lot of what we call smokes may be there. So we can say the induction cooking is planet friendly, and we can say they are easier to clean. As I told you, it's efficient in terms of energy use, and induction cooktop heat is faster and distribute heat more evenly. That is one of the advantages of the induction cooker. It is to cook the food evenly, and they are completely safe as they heat only when steel or iron element come in contact. See, so that is safe. If you don't put any pan or vessel or any type of vessel on the induction cooktop, it won't work. Okay, so it works only when there is a steel or iron pot. So that are the advantages of this induction cooking. And there's a possibility of few questions. Maybe there is a induction stove is better than gas. As I told you, it is better in terms of energy efficiency. And maybe another question is induction cooktop use more electricity? No, actually there's a misconception that misbelief that induction cooktop uses more electricity. Uh, if somebody faces this problem, that is not due to the induction cooker. It may be due to the so-called pot size mismatching. If you use small pot for a big burner, uh, that really affect the efficiency. And at the same time, if your vessel is not compatible with for induction cooking, that also creates the efficiency, or that also affect the efficiency problem. So that is the reason behind some people, they have a complaint that the induction cooker that cooking that took more electricity. That's the problem with their way of cooking, not with the instrument. uh, that's the main problem. Then other questions maybe there, can you touch the induction stove? Is, of course, as I told you, it works only when there's an electromagnetic interaction. Okay, so some people, they are raising a question that, see, there's a strong electromagnetic field, very high electromagnetic field, whether it react with the people, those who are suffering or those who are wearing pacemakers, like heart disease people, they are using pacemakers. uh, but as you know, the field that decreases rapidly rapidly with the distance. The electromagnetic field or the magnetic field that decreases rapidly with the distance. So as we move from the electric cooktop, the field is reduced considerably. So it may not work, but there is an advice that better to consult your doctor. As per the advice from the doctor, you can do this type of things. And another thing is question, maybe there commonly used questions are, induction cooking is expensive or not, or induction cooktop is expensive. I think now it is not expensive. Initially, see, as I told you, in early development time, it's around 1 lakh rupee. Now it's, I think it's around 3,000 or 4,000 we can buy, and it lasts around, or it is designed for 30,000 hours. Okay, it is 30,000 hours. That is a lifetime of an induction cooktop. That's about the induction cooking. Now we are moving to the another cooking method using electromagnetic electromagnetic cooking, using electric field or electromagnetic field. That is nothing other than the microwave oven. Microwave oven uses microwaves, which are basically radio waves, to cook the food. And this micro oven is a kitchen appliance that cook the food by means of high frequency electromagnetic wave called microwaves. Microwaves are absorbed by water, fat, or any other sugar or certain other molecules. Consequent vibration produces heat. See, in induction cooker, the electric field or the magnetic field that generate heat within the pan or pot, but microwave oven which directly heat the food material through the interaction of electromagnetic waves with the food material. It does not heat the atmosphere itself. And as I told you, it uses microwaves. Microwaves are electromagnetic waves which are non-ionizing wave. As you know, the electromagnetic waves, we can classify these electromagnetic waves depending upon its frequency or its wavelength. Low frequency to high frequency, we can say, AM radio wave, short wave, then very high frequency wave FM, then microwaves, infrared, visible, UV, X-ray, and gamma. UV, X-ray, gamma, they are ionizing waves, but microwaves are not. They are non-ionizing electromagnetic waves. See, these microwaves are again further classified for special purposes. See, it's for military and search radar purposes, UHF broadcast TV, cellular phones, and see the microwave heating and satellite communication, then micro relay and missile seeker and GPS system. See, the micro band is again further classified, and you can find this blue part, which is 2.45 gigahertz, which is exactly 12.24 centimeter. That is the frequency of microwave. And there are incredible science and engineering behind the discovery of microwave oven. As many of you know about the discovery of microwave oven, it was invented by Dr. Percy Spencer. And like many other discovery, this discovery is also an accidental discovery. American engineer Percy Spencer, he was carrying out some experiment with a magnetron at a Raytheon manufacturing company. He was working there, and this magnetron was at that time used for guiding aeroplane and ships, especially for difficult atmospheric conditions. And one day, while he was working with this magnetron, and he had one chocolate with him, and he found that his chocolate is melted, and he realized that this is due to the electromagnetic waves coming from the magnetron. And very soon he realized that this magnetron or electromagnetic wave, so-called microwave, can use it for cooking the food. And he patented this technique, and this is the actual or patented diagram of this the so-called microwave oven. And if you are moving to the brief history of this microwave oven, Raytheon later licensed its patent in 1955, and later in 1965, Sharp Corporation, they developed the microwave oven with a turntable technique that I will tell you later. And 1967, Amana Corporation, they developed countertop microwave oven. And at that time, microwave oven, they are used for many industrial purposes rather than cooking. And the first food deliberately cooked with the Spencer's microwave oven was popcorn, and the second one was egg, and that actually explodes at the face of one of the experiment. And this is the some of the old photos of microwave oven. The first one is in developed in 1961, and this one is 1980. And late 1970, technological advances that advances rapidly falling the prices of microwave oven. And before discussing the working of microwave oven, I would like just mention the parts of this microwave oven. As you know, there is a supply, electrical power supply, and there is an high voltage capacitor and electronic circuit, and there is a magnetron. Actually, magnetron is the heart of this microwave oven, and this microwave oven is magnetron is the heart of the microwave oven, and it is guided through the waveguide, and there is a stirrer, and there is a turntable, and this is a cooking cavity, and there is a door, and within this door itself there is a window which has a metal mesh. There's a metal mesh itself. These are the parts of this microwave oven. In microwave oven, as I told you, there is a high voltage capacitor which transferred our normal power supply. Hello, the screen is visible. Any problem, Praveen sir? Hello.
Okay for me, sir.
Okay. Okay, see this power supply, high voltage capacitor, actually that capacitor along with the transformer that actually raises the voltage to 4 kilovolt, that is necessary for powering the magnetron. In magnetron, there is a heating element. This heating element actually generates the electrons, and there's a circular magnet, and this heating element, this electron generated by the heating element forms a circular loop. There's a fundamental theory in electrodynamics: accelerating charges always emit electromagnetic radiation. So this circulating electric charge or electron that is responsible for the generation of microwaves. Okay, these microwaves passes through this cavity, passes through this waveguide, and again means pumped to the cooking cavity. That actually what happens in this microwave oven. Now moving to the working principle. See, inside the strong metal, there's a microwave generator called magnetron, as I told you. When we start cooking, what happens is microwave generate the microwave, then passes through this microwave waveguide and pumped to the channel, and it passes through the food material. And this many of the food material have water content, and this water content molecule that starts to vibrate just like this. Means the cooking is nothing other than the energizing the water molecules. This water molecule starts to rotate or vibrate depending upon its dipole moment. So the microwaves bounces back and forth of the reflective metal walls of the cavity. So it penetrates the food material, penetrates into the or inside the food material, and the water molecules or fat content or some other molecular structure that may start to vibrate, and this vibration leads to the generation of heat. That means heat is generated within the food material. That is one of the peculiarity of this microwave cooking. So vibrating molecules have heat. So the faster the molecule vibrate, hotter the food becomes. That is the what happens. That is what happens in the microwave oven. And in microwave oven, there's a possibility of hot spots, which means that hot spot and dead spot, which means that there is a possibility of some region may not get heated. This is due to the cancellation of the electromagnetic wave. As I told you, the electromagnetic wave reflected back and forth between this conducting or cavity. There is a possibility of cancellation, and this can be avoided by the turntable techniques. As I think many of you have noticed that the cooking vessel is always rotating while we are cooking with microwave oven. The turntable technique, which is used to avoid the dead spots. So next is, as I told you, there's a question that whether it's inside out. Yes, the heat is generated within the microwave, within the food material itself. In conventional cooking, most of the conduction from outside in, just like first flames are there, then the heat is transferred to the conducting material, means the vessel, then after that heat is transferred to the food material through conduction. But in this microwave heating, heat is generated within the material itself, but it is not actually like that, because there's a conduction also. As I told you, the microwave that penetrate into the food material, but it cannot penetrate for a long distance, maybe over 1 centimeter, 2 centimeter itself. Just like a swimmer jumping into the water, say he cannot go beyond a limit. Okay, because his energy may lose. So just like that, this microwave may lose its energy. It cannot go beyond a limit, but it generates heat within the food, and the heat is transferred to the other parts of the food material. That is what actually happens. And there's a possibility of uneven heating that I already told you. And another problem with this uneven heating is the food composition and geometry. We know that the food that we are planning to cook has different conductivity, as I told you. Some material have higher conductivity, some material have lower conductivity. So there is a possibility of uneven cooking, but that doesn't matter too much. So that's the inside out. That's the thing about the inside out question. And another one is whether it is efficient or not. People are always worried about the efficiency of not the microwave oven, all the electronic gadgets. Micro oven, they are so quick, and so we can say it's efficient because they channel heat the energy directly to the molecule inside the food. See, even induction cooker, they heat the pan, then the heat is transferred to the food material. But in microwave cooking, the heat is directly transferred or heat is generated within the food itself. So in terms of efficiency, we can say it is highly efficient. And as I told you, we don't have to heat up the oven itself before you can cook. You don't want to heat the oven itself, microwave oven itself. Microwave heats the food like a sun heats your face by radiation. We can say in terms of efficiency, we can say when we stand in noon time, uh, how we get heated from the sun. So just like that, by through radiation. So in terms of that, we can say it is highly efficient. But that is not the whole story, because in terms of efficiency, that is not the whole story, because a physicist Tom Murphy, he compared the energy efficiency of different methods of boiling a water and found that it was only 40% efficient, which is about half the efficient as using a electric kettle. In that experiment, what he did is he boiled a glass of water using this microwave and the electric kettle. So, and he found that it is not that much efficient if we compare with the electric kettle. So we can say it is efficient in terms of means some sort of food. Not we cannot say it is highly efficient for all sort of foods. And we know that another limitations, we can say, even in limitation, microwaves have limited roles in professional cooking. That is one of the important thing we have to note. It is not used in professional cooking because its boiling point temperature of microwave oven will not produce the flavorful chemical reactions that frying and browning or baking the higher temperature. That's one of the main problem with the microwave cooking. So after this microwave cooking, it may not produce that sort of smell which was produced by high temperature frying or browning. So that is one of the problem with this microwave oven. Now we would like to discuss about the possible risk factors of this microwave oven. The first one is safety, another one is safety within means within this microwave oven, and another one is effect on nutrients, role of containers and high temperature effects. So first is the safety. I would like to ask one question: are you afraid of standing too near to the microwave oven? As everyone knows, microwaves, they can damage living cells and tissues. Of course, there are a lot of reports that microwaves or prolonged use of cell phone or prolonged use of microwaves that actually harmful to the human body. But in microwave oven, we know that there is it is surrounded by strong metal boxes. Metal boxes means microwaves cannot pass or absorb by metal pieces or metal. It always reflect. So the generated microwave, which is always confined within this microwave oven, it is surrounded with metal boxes. There is less chance of leaking out, and there is a well-defined control unit and interlocks also. And at the same time, you can see that there is some metal mesh which is in the window of this microwave oven. This metal through this metal mesh, you can see what actually happens inside this microwave oven. And the holes of this metal mesh, it is very too small so that the microwaves cannot leak it through this metal meshes. And this microwave oven that cannot run when door is open or improperly latched. So you cannot work with the microwave oven when the door is open, because there are a lot of sophisticated control system. And at the same time, you should remember that, see, the microwave oven, that produces the microwaves, but as I told you, its strength decreases as the distance. If we move from this microwave oven, the effects decreases considerably. Its effects decreases considerably. Another safety aspect of this microwave oven is safety within. What happens is, another hazard is the resonance of the magnetron tube. As I told you, magnetron tube is the heart of microwave oven, which generates the microwaves. If the microwave is run without an object to absorb the radiation, or that means there is a possibility of standing wave, which is the energy is reflected back and forth. When there is a possibility of standing wave that creates a overload and burnout. Another problem is just like a dehydrated food, or food is wrapped in aluminum foil. You may heard about this aluminum foil, or in metal boxes which does not arc. That is problematic. That is one of the problem within this microwave oven. And the previous slide we discussed about the safety hazards outside the microwave oven. Next question may be what are the effects of nutrients? As everyone knows, any form of cooking that will destroy some nutrients in the food. And the key variables are how much water is used, because nutrients are leached into the water during cooking, and how long the food is cooked, and what is the temperature. That is the main point of the effect of nutrients, or the loss of nutrients in the food. In micro cooking, as I told you, it's very fast and it's very quick, and it does not use as much water. So there is a possibility of leaking or leaching into the water is very less. But at the same time, its temperature is much higher than normal cooking. So like other heating method, micro cooking converts the vitamin B12 from active form to the inactive form. Microwave food can get locally hotter than other way of cooking, so leading to the faster breakdown of vitamin B12. I just mentioned only one vitamin. Other nutrients are also maybe dissociated. So in general, we can say microwave destabilizes the active protein and biomolecular compounds. That is one of the problem with this microwave oven. And another one is the problem with the containers. So as I told you, all the containers cannot be compatible with the microwave oven. So I think you can find a list of containers which can be used for used in microwave oven. Metal, it cannot be used because the microwave reflected by this metal surface or metal vessel. So microwaves cannot be microwaves may not be able to get into the food. So metal vessels cannot be used for microwave cooking. Only some sort of plastic materials can be used. But by considering the plastic material, only good quality plastic materials can be used for microwave cooking. Otherwise, what happens is this microwave reacted with the bad quality plastics, that the reactions may be carcinogenic. These plasticizes leaching into the food. That is leaching into the food that may create problem. That is one of the problem with this microwave cooking. We should aware of the quality of vessel that we are using for microwave cooking. And another safety issue is the high temperature effect. That is nothing other than the water. The first one is the water explosion. Water explosion is see, the homogeneous liquid or water that may sometimes superheat. So if you disturb the water, or if you put some sugar or something that like that, what happens is due to nucleation, it explosively boil. That is one of the hazards that may occur, but it is not usually happen. And the closed containers such as egg that can explode when heated in microwave oven. We cannot directly cook egg with this microwave oven. Okay, so this is due to the pressures that is generated within this egg itself. And some insulating plastic forms of all types generally contain closed air pockets. See, in some sort of vessels, bad quality vessels, there's a possibility of closed air pockets within the vessel itself. That also creates problem. Not all plastics are microwave safe. Some plastics absorb the microwave, as I told you, that may be dangerously hot, that becomes dangerously hot. At the same time, that may reacted with the microwaves, and some plasticizers may be as the byproduct that may leach into the food material. And products that are hotted for long time can catch fire. That is one of the problem. And I would like to tell you that microwave DVD disc like CD or DVD, they are showing an effect of electric discharge that I will show you in the probably in the next slide. I can show you what happens if you put place a egg in microwave oven and electric circuit or electric bulb or DVD. I think the screen is visible to you. Praveen sir?
Yes, sir. Yes, sir.
The egg is exploded. See, next is electronic circuit. If you are placing electronic circuit in microwave oven. Say electric bulb. Next is what happens. Say CD in microwave oven. Actually, this is due to the electric discharge. So the innovative alternatives for our conventional cooking changes the lifestyle. So that's about the my talk. That's about how the electric field cook your dinner. So once again, thanks to Department of Physics, St. Joseph College, Moolametham, especially Dr. Praveen for inviting me to handle a section on your program as part of your student enrichment program. And I would like to thank the fellow participants, my colleagues from my own college and my students and other students from nearby colleges. Thank you. Now you can, if you have any question, you can post your questions in the chat box. Definitely, I can share my views on your question. I'm not expert. I'm not the final authority in this field, but I can definitely share my views on your question. Thank you.
Thank you, Dr. Somesh George, for the relevant and informative talk. Now the platform is open for discussion. The participants can ask doubts by unmuting or by putting questions in the chat box. Sir, there's a question.
Yeah.
Will we get shock if we touch the utensil placed in the induction cooker during its working?
Actually, it does not. No. The answer is no. Probably the doubt maybe came from the fact that there is an eddy current. Whether the eddy current creates any shock, then probably that is the question. Actually, the eddy current does not do any work. Okay, so it's a circulating current, and as I told you, this current is just like a loop. It does not produce any shock.
Okay, thank you, sir. There is another question from Mr. Lindo. If eddy current is responsible, then aluminum utensils should be able to generate heat.
No, okay. So actually, aluminum utensil does not produce this eddy current. Actually, what happens is there is, if you place an aluminum vessel, there is no electromagnetic reaction between the burner and the aluminum. That is a actual reason. There is no electromagnetic reaction between the aluminum and eddy current is not generated for aluminum. Not only aluminum, copper is also not working. It works only for ferrous material. I think I told you that the importance of ferrous material is there is an unbalanced electrons. Say unbalanced electrons means there is an electron spin which is up for electrons, more up spin electron spin than down spin electron spin for iron. It is not happened in aluminum.
Sir, another question. Can induction cooker cause explosion?
I haven't seen any report about the explosion of induction cooker. By what means you are telling? By by which means by electrical problem or
I
something
think
like.
I think they're asking, is there any accident, any reported such cases?
I haven't
Is
noticed
there
any reported hazards with the explosion of induction cooker. I haven't noticed it.
Okay. Sir, another question. When I connect an induction cooker to plug, I result to power of the power failure. I think maybe power failure of the whole house. MCB turned off. What's the reason, sir?
Probably that is within your wiring problem.
Wire.
It won't work. Maybe improperly grounded. Maybe that is the reason. That is the reason. Grounding.
Another question. This induction cooker is rated as high voltage instrument.
Yeah.
So is there more current conduction while we using the induction cooker?
Actually, it uses high frequency current. It uses the high frequency current. This actually in Kerala or India, the supply voltage is 230 volt, and this through this electronic circuit, this electronic circuit pump the high frequency, which means that 24 or 25 kilohertz frequency current. It actually drives, and it does not. The report shows that it does not means use more electricity. No, there is no solid proof till now.
Okay, so another question. What happens if a metallic iron knife is placed inside a microwave oven? Will it get heated?
Question is there. The microwave oven, if you place a metallic something, see, metal always reflect the electromagnetic waves. Always reflect. But if you keep a knife inside this micro oven, there's a possibility of heating. There's a possibility of heating, but actually it reflects. As you know, in old what we call not escalator, just like see closed containers. You know what we call. Okay, it's closed containers. See, if you are placing a mobile in a closed container, see, it won't work because microwaves cannot penetrate within this this closed container. Just like a tiffin box, if you place your mobile phone within tiffin box, if it is closed, it won't work because this metal surface that reflects the electromagnetic wave. Okay.
Another question. What are the possible negative effects of microwave cooking?
Yeah, negative effects of microwave. There are a lot of reports, but it is not actually the proven one. But I can tell you some of the negative aspects. The one is the container. Actually, the container that creates the problem. If the container is not good, the microwave reacts with this container that creates some plastic. That there is a possibility of byproducts that may be carcinogenic, that may be leached into the food, so that harmful to our body. That is one problem. Another one is, as I told you, it is not used for professional cooking because it does not produce any flavorful reactions. So that is a main problem with the micro cooking. Then coming to the efficiency, see, if you are cooking with a small glass of water, see, and you are giving a high power. So in terms of the input power and the amount of food that you are cooking, that is not efficient. That I think that I already discussed.
Okay. And there are so many messages coming congratulating Sumesh sir. Another doubt:
Thank you.
why does the egg explodes in the microwave? Can that happen with our other food materials as well?
Yeah, egg explodes because of the pressure generated within this egg itself. As I told you, it's a closed vessel, just like a closed vessel. It is not a metallic vessel, but it is a closed vessel. So the pressure is generated within this egg itself. So that's the reason. Okay, then can that happen with other food material as well? See, if you are keeping your food in such type of closed vessel, it will happen. Okay, that's the reason.
Thank you, sir. Another question. What happens when a piece of wood placed in a microwave?
Yeah, if wood that wood contains any microwave compatible or microwave means molecules, just like water, definitely heat will be generated. Okay, if your wood contains water content or some sort of molecules which can excited by this microwave, definitely that heat will be generated.
Praveen sir is asking, if it
Yeah,
is dry wood, then what will happen?
dry wood it may not be. It may not be. But usually, at what extent we can make sure that is dry wood? That's one problem. What extent? Maybe even within this wood, there's a possibility of some sort of water content. Okay, that usually happen.
Okay,
That's
okay, sir. Another question. Is there any frequency interference
huh.
with the other microwave devices, with the microwave oven?
Yeah, micro oven works only at a frequency of 2.45 gigahertz. It actually it is allocated for microwave oven itself. So
Okay.
in our communication cellular phone also we know there's an allocation for Geo, Idea, or BSNL. I think people may aware of that. So this is specific allocation for the frequencies.
Oh, okay. Can wax react with microwave?
Wax react is actually I'm right now I am not able to answer this question whether wax react with the microwave. I don't know the molecular structure of wax. If as I told you, if wax contains any molecular structure or any component which is microwave compatible, means uh, uh, if the microwave react with any component within this wax, definitely heat will be generated. Actually, I'm not a person to answer this question. I will search and I will let you know later.
Okay. Okay. Thank you so much, sir. Now I'm handing over the session to Mr. Anvin Sunny, Student Representative, Physics Department.
Thank you.
Good afternoon, everyone. Respected guest, Dr. Sumesh George, the speaker of the day, respected teachers, faculty members, listeners, and viewers of various levels, and dear friends. There's a saying that well begun is half done. Keeping aside all the challenges that we are facing today, Department of Physics, St. Joseph's College, Mulamatam, took an initiative and began a physics webinar series as part of Students Enrichment Program. Today, we had its first session led by Dr. Sumesh George, Assistant Professor, Department of Physics, St. George College, Arivitra. We know that food and cooking are part and parcel of everyone's life, and Dr. Sumesh explained it well from the ancient cooking aid to the modern means of cooking, which includes induction cooker, microwave, oven, etc., and its working in detail. At this juncture, I would like to express our sincere gratitude towards everyone participated in this webinar. First of all, I would like to thank Dr. Sumesh George for accepting our invitation and the effort that he had put forth to make this session a wonderful one. He was
Thank
a
you.
former student of our college and always an inspiration and a motivation for his successors of this college. In the name of all the participants, I convey our sincere gratitude to you. Thank you, sir. Next, I would like to thank our principal, Dr. Epipi Koshi, for his concern and support towards our new initiative. Thank you, sir. I also thank Reverend Father Libin Valiabaramel CMI, Barsar, St. Joseph College, Mulamatam, for his blessings and support towards our program. Thank you, Father. I would also like to thank the teachers of the Department of Physics, St. Joseph College, Mulamatam, for their hard work and effort for making this session a great success. Thank you, dear teachers. In a special way, I thank Mr. Amal J. Adagath for his technical support during this session. Last but not least, I would like to thank all the participants and beneficiaries of this webinar. Thank you all for your cooperation and active participation that made this webinar a success. Once again, I convey all our sincere gratitude to each and every one of you. Thank you.
Thank you, Anvin. And now our webinar is over. To get the certificate, please submit the feedback form and the link is provided in the chat box. Once if you won't receive the certificate even after filling the feedback form, please check in your spam folder also for the certificate. Thank you one and all. Thank you so much, sir, once again.
Thank you very much.